Okay, thanks for coming to this relatively early session. There's nothing like a bit of group policy sun on a Sunday morning with a tiny little hangover, is there? So we don't have that much time, 40 minutes, I guess. So you may know these things. If you want to tweet, contact me. Twitter is always a good thing. You may know the main product of our software company, Uber Agent. It's a user experience monitoring agent that works on top of Splunk. So please take a look at that. It's awesome, I can assure you. And one of my earlier achievements includes Citrix Profile Management, at least the earlier version, which we developed at Chicago where I worked at the time, which was later bought by Citrix. And of course, all the bugs that you may find in Profile Management, I'm not saying it does have any, but if you find one, they were added at Citrix after the purchase. Now, in this session, I'm going to present all kinds of numbers and facts about group policy. Where I did take measurements, they were all taken on server 2012 with ZM 7.6. And this is a very important thing. Whenever you measure something, make sure, especially in a ZenF environment, make sure you're in a steady state, meaning the system is booted up. So you're not doing it for the first time, so ignore the first measurement, and then in this case I measured everything for at least 3 times, and then I'm going to, the numbers are always the averages of at least those 3 things. Now, how did I measure the numbers? You see here, of course, I used our own product, Uber Agent, which gives you a lot of detailed information about what is happening going on during Logon and how long it takes and so on and so on. If you cannot use Uber Agent, that is really a shame, but if you really cannot use it, take a look at the Windows event log. There's a kind of obscure session, section in the event log that most people, I guess, don't use and maybe don't even know about. That's in the application and what's it called? It's to everybody's application and well, it's in a subsection of the event log. There's a group policy section, and there you'll find information that is logged about the processing of group policy, including how long it takes for various modules to process. We'll see about that very soon. Now, let's take a few minutes by making a few enemies here. gp update/pause. Many people, when they change something in group policy, this is the command they run afterwards to get the changed settings onto their boxes. Don't do it. gp update/pause is only required if your group policy infrastructure is broken. If not, if it's not broken, the changed settings will automatically propagate to your system. Just run gp update without that /pause parameter. Group policy caches the settings on the group policy client on the local machine, and it knows which settings it has applied and which settings, which GPOs are from which state. And so if you update a GPO in the domain, it will compare it will find out that one specific GPO is updated and bring in those changes. So you don't need /pause unless your environment is broken. In that case, you shouldn't use that command, you should fix your environment. Now, let's start with some boring talk about what the architecture of group policy. I've talked a little bit about this in my Uber Agent session yesterday. You probably know that group policy is actually an extensible framework. It's not one monolithic thing. It consists of a basic engine and then many, many modules. Of course, Microsoft provides both the engine and many different modules as part of the operating system. And so other vendors like Citrix, they add their own modules. Modules are called client-side extensions, or in short, CSEs. We'll hear that term a few times in the next minutes. Now, when you look at Group Policy Editor and expand all these categories, each one of those is represented by a different client-side extension. In other words, a different module. That means whenever you configure a setting, whatever, in preferences to create a shortcut, for example, you will invoke a different module on the client where group policy is applied. Now, let's take a look at the number of modules that are there. With Windows 2000, we only had 9. Then with Windows 7, already 42, and Windows 8.1, already 47. So this shows that Microsoft adds new capabilities, new management capabilities to their operating system. They do it, well, kind of in a silent way, but still we can do more and more with group policy over time. Now, client-side extensions are DLLs. And DLLs need to be registered somewhere. They need to be so that the group policy engine can find them. But there's this registry key here, HTLM, blah, 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 GP extensions, and you can find one subkey named, easily decipherable with a GUID, well, at least that way it should be unique. And so each of these keys stands for one CSE. And in that key there are of course a few values that configure the key and point to the DLL that represents this specific client-side extension. Now in that, below that key for each of the client-side extensions there are a few interesting values. 2 of these are quite, influence the way the group policy, this client-side extension processes its settings. And 2 of these 2 are especially interesting. One of those is no GPO list changes and the other is no background policy. And you may notice this tradition of double negation, which is so totally stupid, but they not only have that in the UI, they even have that with their registry values. It's totally confusing. So no changes, 0, which is also no. Double negation means yes. Well, that was easy, wasn't it? So this means, does that client-side extension process process its settings even if nothing has been changed? And so in other words, does it get called by the group policy engine if nothing has changed? And as you can see, the default is yes. So, and that is the actual value that is true, that is set for many client-side extensions. So many extensions get called even when nothing happens, just regular background refresh. That adds quite a bit of load and is not so well known, I would guess. And the other is, we'll talk about this a little bit later. When you log on, group policies gets applied for your user for the first time, but then periodically in the background every 90 minutes or so. And this value configures whether the specific client-side extension, a specific module gets called during such a background refresh, yes or no. So, okay, talk about that. Now, when we have these 47 different modules on Windows 8.1, the question that sometimes pops up on the internet, what is the order in which those are processed? Now, this is actually simple. First, we get the registry policy, meaning the administrative templates. That is also one client-side extension that just writes the configured values to local machine software policies, basically, to be picked up by the application or in question. Now, after that, we have all the other 46 client-side extensions, and they are processed in numerical order of the GUID. That means, let me go back a few slides. Where's that? Okay, so the group policy engine starts with this one, 0AC, and then moves down like this. So this may make sense or it may not for you in your specific environment, but there's no way to change that. That means if you, for example, want to set an environment variable before you run a script, the order may be right for you or it may not. If it doesn't, well, you're out of luck.
But you're able to set the order of group policy processing in the group policy management console. So you can separate CSEs, for example, in 2 different group policies and do the one before. Do you know what I mean?
You can configure the order in which GPOs are processed.
Yeah.
but if you have, but that is only important if you have one at the same setting in two different GPOs. So if you set a environment variable to A in one GPO and to B in the second GPO, of course the order is important if you get, as a final result, if you get A or B. But as in my other example, which I used just now, if you want to set an environment variable before you call a script, either the order is correct or it's not for you. There's no way to change it.
Yeah, but if you set the environment variable in another GPO definition.
There's one thing to keep in mind. Each CSE is only called once during group policy processing with all the GPOs. So the CSEs are called once with 50 different GPOs.
So it's merged.
They're merged. Yes. Yes. Yeah. Okay, let's move on. Now, let's start with some numbers here. If you look at popular CSEs like the one to create a shortcut or create an ini file or set an environment variable or all of these others that are available, what is the overhead that such a CSE have? In other words, if I don't do anything, what's the minimum processing time? That after all, the DLL needs to be loaded, it needs to be called, and given some stuff to work, it will have to initialize and things like that. So as we can see, there's quite a difference between various of the more popular CSEs in the overhead they generate. You can see the registry, which is registry CSE, which does the administrative templates processing, which is in the area of something like 17, 18 milliseconds, whereas the shortcuts CSE is nearly at 80 milliseconds. So that's something that might be of relevance. Now let's think about where the client-side extension's settings are stored. After all, well, when the group policy engine calls a client-side extension, that extension needs to have data to work with. So in other words, what are the settings that the administrator configured that the client-side extension should process? If for the administrative templates, these settings are written to a file called registry.pol, and that registry.pol is stored per GPO on the domain controller. As you can see here, it's in the sysvol share, and there we have a variable that stands for the GUID of the group policy object, and then the user subsection or the computer, depending on where you configure settings, we have that registry.pol file. Now with group policy preferences, it is different. They store their settings in XML files that are also stored in the respective group policy object directory on the domain controller, but in a different subfolder. You can see here there's user preferences, environment variables, and in case if I configure something for the environment variables CSE, I've got an environment variables XML file. Now this means that if I configure settings for different group policy preference client-side extensions, like I want to set an environment variable, a registry key, and the other things, several different files are being created on the domain controller. And when group policy is being processed by the client, those files need to be fetched, of course. And you all know, when you log on with a profile that has thousands of files, that can take a little bit of time. Well, the same is true for group policy. If group policy needs to download many files in order to get its settings, what it is to do, that obviously takes longer than when things are stored in just a few files. Now, the registry.pol format is talking very briefly about that. It's a binary format, so it's not that easy to decipher. There is a link in the presentation, the slide deck, which I'm of course very happy to share, that points to the MSDN documentation on the format. So this binary format is documented. You may have heard of GPO Guy. I think the guy's named Darren Maralia. He's been a GPO MVP for seven or 8 decades, I think. he wrote a viewer utility that lets you find out what's actually stored in one of those registry.pol files. And there's near the bottom there's a link to a VB script that lets you modify those things in case you need to do something like that. I hope not. Now, what I talked about just now, let's look at the impact of having the GPO the CSE settings spread across the many different files. To do that, I created, I wanted to set 20 different environment variables via group policy preferences. Pretty easy, of course. I did that in one test case in one group policy object. And in the other test case, I created 20 different group policy objects, each with that one setting. And let me just briefly go back. As you can see here, if I create 20 different group policy objects, I will get 20 folders, or directories actually, like this, and 20 different settings files that need to be fetched by the environment variables client-side extension. So let's take a look at the effects of that. So there definitely is a difference. This is per setting, so per environment variable. In my environment, which may of course be very different from your environment, but in my environment it took 10.5 seconds, milliseconds, to process each individual setting if they're in different GPOs, and but the other way around. 10.5 seconds per setting if they're in the same GPO, and 14 seconds if they're in different GPOs. Obviously, the difference is due to the additional files that need to be fetched and processed by the group client. Now, let's take a look at an additional look at internals. Group policy has various modes. I mentioned that briefly already. We've got foreground processing and background processing. Foreground is when the computer starts up or when the user logs on. And background is every 90 minutes after that, with a certain random offset so that not all clients hit the domain controller at the same time. As you have seen, or as we have discussed briefly in that a little bit earlier, many client-side extensions are invoked during background processing, even if nothing has changed. And that is governed by this setting per client-side extension we talked about earlier, no GPO list changes. And you can also configure that via group policy. Yeah, that's actually kind of funny to configure group policy via group policy. Okay, but I digress. Now, in addition to the foreground and background processing, we have two additional modes. Those are synchronous and asynchronous. Synchronous obviously means other processes are halted until group policy has been applied, and asynchronous means, of course, well, things are not stopped, it runs in parallel to other things. Now, this is relevant primarily for the user logon phase, where synchronous means logon is delayed until a group policy has been fully processed, which has good and bad side effects, of course. And asynchronous means, logon goes on while group policy runs, processing happens in the background. That sounds like a great idea. That's why non-domain joined machines do that by default, starting with, I think, Windows XP. But in an enterprise, you typically want a controlled environment. And typically, when the shell is started and the applications are run, you typically want all the settings to be already in place. Otherwise, the shell might get started and certain restrictions or configurations might not apply yet because, well, they come too late. So you typically, in an enterprise environment, want to set this setting, always wait for the network at computer startup and log on. And that name is totally stupid, and in German it's translated in even a worse way that makes it really hard to understand what it actually does. But it's effectively, it switches group policy processing during user logon to synchronous. In other words, group policy, the logon is delayed a little bit, yes, that is a trade-off, but you have everything guaranteed to be in place when the shell is started. Okay, now, with group policy there are various timeouts. Well, first, there's a timeout for all of group policy processing, which is 60 minutes. Now you may think, okay, who is crazy enough to need that? Well, if you are crazy enough to deploy software through group policy, you might need that. Well, first of all, don't do that. But second, if you do, if you have a really badly behaving application installation package, well, that will be continued asynchronously in the background after 60 minutes. Well, that's certainly to guarantee a great user experience. Now, when you run logon scripts through group policy, those have a timeout of 10 minutes. Those values are not widely known, so that's why I list them here. If you use WMI filters, we'll talk about those in more detail, that WMI filters can be used to to have a certain GPO apply only to certain computers, for example. Well, WMI filters have a kind of a bad reputation, and we'll check if that is validated. But in any case, if you have a WMI filter, after 30 seconds, it will be killed and treated as false. So the Google engine just thinks, okay, you took too long. I'm going to say that you reported back that this GPU is not to apply. And then when you map drives through group policy preferences, we have a timeout of 30 seconds. Now in most scenarios, that timeout is not required, because the typical actual timeout, when you try to map a drive to a machine that doesn't exist, is somewhere in the area of 5 to 7 seconds. I've tested that in various scenarios. Now 5 to 7 seconds is already pretty bad as an unnecessary delay, but the worst thing, what is even worse, is that you get it per attempted drive mapping. So if you have, well, kind of a little bit of chaos in your GPOs, and some of the drive mappings are pointing to servers that were migrated a few decades ago, then if you try to map 4 drives, you get at least 20 to maybe 30 seconds of delay for each single logon. And this may sound like stupid, me talking about this at all, but this is so common. I don't know in a large percentage of actual enterprise environments there is at least one delay like that. Yes.
I actually found one due to Uber Agent.
Oh, thank you very much. Yes, thanks, John. Yeah, Uber Agent troubleshot or looked at an environment with Uber Agent and found that that was the case for a very significant delay, I take it. Thanks. Now, being knowledgeable about XenApp, you certainly know all about loopback modes. Client guys are sometimes a little bit confused by that. Basically, we have, you know, of course, there's the computer section and the user section of group policy, and we've the computer object in AAD and the user object, and normally those two are very separate. But with loopback mode, that is kind of changed. I'd start with replace mode, because that is easier. With replace mode, the user object is ignored, and the user settings are taken from the location of the computer object. That is all. Easy and simple and fast. There's also merge mode, and in merge mode we get 2 passes in which GPOs are evaluated. In the first pass, the user settings are taken from the location of the user object. And then, after all that is done, we get a second pass where the user settings are evaluated and taken from the location of the computer object. Now, if that sounds confusing to you, That is because it is. Firstly, this is a very bad practice because it gets confusing which settings do actually apply. So never do that. The second thing is it takes longer because the group policy engine has more to do. So that's another reason to avoid merge mode. Now, if you need to troubleshoot group policy, you can enable logging by setting this value here, GP service debug level to whatever, and in that registry value key here, and you need to create the directory. This is a bit confusing, so you need to create this window debug user mode directory. If you don't do that, the things will not be logged, so you won't find the log file afterwards, which can be confusing. But if you do create the directory and that registry value, you will find a file gpservice.log, and that file is a little bit, how do you say, arcane. There are easier log files to read, let's put it that way. To help with deciphering that log file, there's a Microsoft blog that helps you decipher it. You can find it at this URL. That blog is about 10 million characters and 5,000 lines, whatever. So there are easier files to understand. But if you have to deal with it, please take a look at that blog article. And logging for preferences can be enabled independently of that. You've got this location in group policy to do that. Now, another not well-known fact is that group policy is single-threaded. So if you have that beautiful new 98 core machine, it won't benefit from. The group policy won't benefit from it. Logons, group policy processing will not be faster. Per individual user, there's just one thread that processes all the different clients and extensions one after another. There's nothing done in parallel, except well, in one specific scenario where you have background processing. In that case, user and computer settings are processed in parallel, in other words, independently. Now, if you want to control which settings are applied to which machines or which users, you have a few tools at your hands. Of course, you can use OUs and link GPOs to different OUs. You can set permissions on GPOs so that the GPO is not applied for every user or for every computer. This works for computer accounts too. If you acquire permissions, in order for group policy to get applied, you need two permissions, read, and there's a separate permission that's called apply group policy. Now, those two are fairly well known, so I won't go into that in more detail, but the interesting things we'll see a few numbers about right now is WMI filters and item level targeting. With a WMI filter, you can configure a WMI query. And that WMI query is run before a group policy object is applied. And if that WMI query returns true, the group policy object is applied. If it returns false, the object is ignored. So this WMI query, so it's always set or run per entire GPO. So if that GPO has 10,000 settings, there's one query that determines if those 10,000 settings are applied, yes or no. Item level targeting is different. It is available for preferences only, but it is available per setting. So you have that one big GPO with 10,000 different settings. You can, or in other words, you have to set item level targeting on each of those settings. And only with registry values, which is only one of the many different things you can do with a group policy preference, you have the concept of collections, or groups, where you can group many different registry values into one group and apply one item level targeting filter to that entire group. Yes, John?
If you have conflicting settings in the security and WMI filter, which one would win? So
Yeah, the question was if you have conflicting filters in both in WMI and item level targeting, what happens?
Or no, in the security group.
Or in the security group. Well, these things happen one after another. Basically in that order. First, the group policy engine looks at the OUs and what is linked to the OUs. Then it takes all those GPOs that are linked, and then it looks at each of the GPOs permissions. And if the permissions don't fit for the current user or current computer, the GPO is ignored. And then for each of the GPOs, the engine checks if there is a WMI filter. And it runs that WMI filter, and if the result is false, the GPO gets kicked out. And then for all these settings, the preference settings in the remaining GPOs, the item level targeting filter is evaluated. Now, I mentioned earlier, WMI has a bad reputation, and that justly so. WMI is truly evil, but not in all scenarios. So it might be okay to use it for group policy processing, or it might not. So let's evaluate that a little bit in more detail. First, if we have a specific WMI query string, there we can measure how long it takes to execute with PowerShell. So in this case, I'm using this string as an example. Select everything from sorry, Win32 operating system where build number is larger than 7,000. That's my WMI string. And if I use the PowerShell command measure command, I'm running it with that measure command 1,000 times. And I'm interested in the total number of milliseconds this command takes to execute. So let's take a look at execution times of a few popular queries. First here, I want a specific operating system version, let's say at least Windows 7, that takes 17 milliseconds to execute. If I want a group policy object to be applied to 64-bit Windows only, I could use something like this, which takes 18 milliseconds. If I want a specific keyword layout, in other words, I want this to apply to German machines only, not to Dutch or English or French machines, takes 8 milliseconds, which is quite okay. Or if I wanted to apply a GPO to apply only to specific computers that have a specific name, takes 7 milliseconds. It's all quite good, I would say. And this is once per GPO, so it's not like this is done 1,000 times per logon. This is basically just a few milliseconds that are added to the logon. But there's one really evil WMI class. The WMI class is that this Win32 computer system. The bad one is Win32 product. That stands for the installed software. Don't touch that with a 10-foot pole. You see, this takes more than 11 seconds to run. So you don't want to do that during user logon. In this case, we would target with this GPO only machines that have Adobe Reader installed. But if you need something like that, figure out a different way to do it. Now, this is, if you search for WMI query and whatever, certain operating system, things like that, on Google you'll find many examples for these WMI query strings, because they are kind of arcane and not well documented. But you find lots of examples for popular queries, so that is pretty easy to use. But nearly all of the examples use a format like that. So in other words, select everything from blah 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 where blah 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 something else. There is a more efficient way to write these queries, and that is not to ask WMI to give you all the attributes, in other words, not select everything, but only select one specific attribute. There is a little optimization that can about half the execution time of these queries. Let's take a look here, next slide. We're using, everything is identical, but we're using a specific, we're asking for a specific attribute, like select name from computer system, whatever. It's not important what we fill in there, because we're not using it anyway. It's just something that, so that the syntax of these WMI queries is okay. And let's, I'm going back to the other slide, so let's compare the numbers. So we have 9 milliseconds instead of 17. and we have 18 that get half, more or less half to 8. So that is quite a nice little improvement. It doesn't help much with this reader thing though. So let's see how I'm doing for time. Badly. Okay. Now a few more numbers. I took a look at, well, we measured the execution time of the WMI filter by itself, just the WMI query just earlier. And here we saw that these typically take a lot in the area of, well, if we take a look at that one, in the area of 4 to 9 milliseconds, which is not too bad. Now the question is it the same if I use the WMI query in GPO? So is that more or less the overhead that I get when I use a WMI filter? To compare that, I created 100 GPOs, each of them in one case without a WMI filter, in the other case with a WMI filter. And the difference is, well, around 9 milliseconds. So that is the overhead for a simple WMI filter, which is actually not too bad. So it's not evil to use it in that scenario. Now, what about the performance of item level targeting, which is kind of an alternative to WMI filtering? Well, item level targeting generally can be used to reduce the number of your GPOs, because you can have settings for different machines or machine types or different users, and filter on the setting if you want this to apply to whatever 64-bit Windows or 32-bit Windows and things like that. But these filters, of course, take time to run, and there's an interesting Microsoft blog article, there's a link behind this, that says, well, item level targeting is not inherently harmful. So that, in other words, that says it is evil as hell, but not always. But that is a kind of a overreaction, and it is the Microsoft guy who said that. What you definitely shouldn't do in your item level targeting filters, you shouldn't include anything that needs to be created over the network. So don't ask for anything that is stored in AD. So don't perform an LDAP query, for example, things like that. Those can be very slow. But the other settings are actually, filter types are actually normally quite okay. Now an interesting thing is, when you have one group policy object with 100 environment variables or registry values that are set through group policy preferences, if you have, well, let's talk about environment variables. You don't have collections or groups there. So if you want the 100 environment variables to only apply to certain machines or certain types of users, you might have to add the same item level targeting filter to all of these 100 settings. And the thing is, the engine is not very clever in that regard. If you have the same filter for 100 settings, it will run 100 times. So let's take a look at the actual performance. So in this case, I created one group policy object with 100 different environment variable settings. And in one case, there was no item level targeting. In the other case, there was item level targeting for each of those 100 settings. Now comparing those two, we see there is certain overhead of about nearly 20%. And 2 milliseconds by itself is not very important, of course, but if you have hundreds of settings with times those two settings, it may become relevant. Now, comparing WMI filters and item level targeting, both of those don't add too much in terms of a delay during processing, but the important difference is that a WMI filter is configured per GPO, while item level targeting is configured per setting. So that may make quite a difference. The other important thing is that WMI filters are stored in AD. They're not in the file system. They're in the Active Directory database. So if the group policy engine, when the group policy engine needs to determine if a GPO is to be applied, in the first case it needs to talk to Active Directory anyway. And I tried to make that. And so it doesn't have to fetch any files before it can determine, or in order to be able to determine whether to process that GPO. So that is actually quite fast. But item level targeting, the filter string, is stored in those XML files we've seen earlier. So all of those XML files have to be fetched from the domain controller first before they can be evaluated. And in some cases, if it turns out that the settings don't have to be applied, all this fetching, all that delay was for nothing. Now, a few other things. Some people sometimes disable the user configuration of a policy that only applies to a computer, and the computer configuration part or side of a policy that is only to apply to a user. I did that for a long time. So is it worth it? Does it make any difference? Well, if you have 40 different GPOs with just settings just in one side and you disable the other one, well, there is a little difference, but it's not really worth it. So that's a kind of a practice that, well, it doesn't make very much sense, but it's kind of like a myth that has been on the internet for a long time. Now, regarding how you can, from a management standpoint, how you can use your policies, there are two approaches. And I'm not going to say one is better than the other, but there are certain differences. You can use so-called monolithic GPOs, where you have one big GPO with settings from many different client-side extensions. Now, that means if one of those client-side extension settings changes, the GPO is marked as changed, and everything that has been set or configured in that GPO will be reapplied the next time it's time for that. If you have so-called functional GPOs, you have more or less one GPO per client-side extension, so one for whatever environment variables, next for registry keys, and so on and so on, and that doesn't happen. Now, in the last 2 or 3 minutes, let me cover how Citrix handles or fits into all of this. Now, as you know, Citrix settings can be either stored in the farm, that means in the SQL database, or in Active Directory, in group policy. Now, both of those can be used together. And that may or may not be known widely known how that actually works. So let's take a look at that. If you have settings on in the farm, in the database, and in AD, they will be joined by the VDA when group policy and settings need to be applied. So it works correctly, but it is confusing what comes from there. So please don't mix for reasons of for sanity. Generally, when group policy is applied, you have the following order: LSD, easy to remember, LSD OU. So local site domain OU. So that's first local policies, then site policies, domain policies, and then policies configured in a specific organizational unit. So this wins. This has the highest priority. If you have Citrix settings configured in the farm, they come in at that point in time, so pretty early, so they have a low precedence. In other words, if you have Citrix, the same setting configured in the farm and in AD wins. Now, when farm policy is refreshed, when settings are stored in the farm and when settings need to be refreshed, how does that work? First of all, that happens when either the VDA registers with the DDC or when a user logs on. That's at that point in time the client fetches the new settings, and that works. Well, I don't really have time to go into detail, but basically that works by the broker agent. Fetching settings from the farm, from the database, and writing that to a certain location in the file system where they're cached for later reuse. And then you have the Citrix group policy engine service that later takes those basically cached settings and processes them. Normally, when group policy is refreshed at these four events, when the computer starts up, a user logs on, when the background refresh is due, or when I manually use GP update, of course, without force. Now, when Citrix adds a fifth event to that, that is when sessions reconnect. That makes a lot of sense because when I reconnect to a session, it might be from a different device and different settings might be in order. Now, there's one generic Citrix client-side extension, one generic Citrix group policy module, which is called Citrix CSE Client DLL. And this module is called every time group policy is applied. And that it looks at a few undocumented registry values that have interesting names though, like CSE ignored Citrix user policy trigger. You might want to play with that to if you want to hack the way Citrix policies are being processed. And this Citrix DLL notifies the Citrix group policy engine service I mentioned earlier, and the service does the actual work. Now this service, it combines the farm settings that may have been set, that were cached in that file, in the file system we saw just now, and it merges that with settings configured in the domain, in Active Directory, and it writes it caches a few files in these areas, and then writes the settings, computer settings, as you can see, to HKLM, software policy Citrix, and user settings to also to location HKLM, interestingly, but the settings that the part that has the user session ID in it. And I measured the minute. What is the overhead that all this Citrix stuff adds to the group policy processing? And the minimum I found was 80 milliseconds that kind of Citrix wastes or adds or dedicates. Now, you are near the end of this session at least. A few recommendations, basically summing up what we heard earlier. The one thing that impacts group policy processing time the most is the health of your Active Directory and your DNS. So please make sure those are in perfect working condition. If they are, group policy will be probably quite okay. Now, and we also saw that trying to map drives from machines that don't exist is a very bad idea, and it adds about 5 to 7 seconds per attempted mapping. So please make sure you don't have that. If you don't have those two problems, then you're probably already pretty good. Of course, avoid inefficient WMI classes, then this, like this Win32 product. If you want to do some fine-tuning, well, you should avoid the group policy with the loopback merge mode. Use replace mode instead, which is more efficient and also easier to manage and to understand. If you can, try not to spread CSEs across too many GPOs, or we will have many different XML settings files on your domain controller that need to be fetched for every single logon. And of course, if that happens over the WAN, if the client is a different site than the domain controller, that may prove to be really bad. So that would be one thing to check if you're in a WAN environment. And I never thought I would say that, because I always claimed WMI to be truly evil. Well, it is in 95% of our cases, but with GPOs it may be okay to use WMI filters now and then. Well, with stateless machines, SBC and pooled VDI, sorry, you typically want to control the environment, so please make sure that group policy is processed in a synchronous way, so that group policy processing is sure to be over when the user actually logs on. And then we got with Microsoft, in its infinite wisdom, they introduced, they changed the way group policy logon scripts are run. By default on starting with Windows 8.1 and Server 2012 R2, they are run 5 minutes after the actual logout, which is totally stupid. It makes no sense at all. To change that, please use this group list setting where you configure the delay. You can change it to anything, and please change it to 0. I think that's mostly it. Thank you very much. Have a great day.